Section 7.1, Introduction to Periodic Functions. In this section, we're going to introduce the concept of a periodic function. We're going to look at periodic functions through the use of the Ferris wheel concept. We're going to talk about midline and amplitude. So to start off with, we're going to use the example of the London Eye Ferris wheel. The London Eye, also known as the Millennium Wheel, is 135 meters tall, or 443 feet. It's actually the biggest Ferris wheel in Europe and has become one of the most popular paid tourist attractions in the United Kingdom. It's actually visited by over 3 million people every year. At the time it was erected in 1999, it was actually the tallest Ferris wheel in the world. You can find several websites that will talk about the London Eye. So just a few little facts about it before we actually talk about the math behind it. So, first of all, it was designed to celebrate the millennium, the change to the year 2000. It was actually funded by British Airways. It's Europe's largest Ferris wheel. It actually sits on the south bank of the River Thames in London. It can actually carry up to 800 passengers in 32 capsules. The Ferris wheel actually turns continuously, completing a single rotation every 30 minutes. In other words, it goes about 0.6 of a mile per hour. This is actually slow enough for people to hop off and on while it turns. So for what we're going to do, I'm going to actually make the Ferris wheel have a 450-foot diameter because that'll make a little bit easier, a little rounder number. And so here's kind of a picture. It's not really a graph, but it's kind of a picture that just shows the height. And we're going to make a little assumption as we start here that the Ferris wheel actually touches the ground, basically, that when you get on it, you're at a height of 0. So we're going to say that that's a height of 0. You may actually get on a little bit above that, but for our computations, this will work much better. And so then when you're at the top of the Ferris wheel, you're at a height of 450 feet. So what I have done here is I've made a table that would give us an approximate height situation over a time period, and I actually went from 0 up to 40 minutes. And so what we know is we start at a height of 0. We're going to assume on this right now that we get on at a height of 0 and that that's when time starts. What we know is at 30 minutes, we'd be back where we started. So you'll notice at 30, we actually have a height of 0. Halfway in between 0 and 30 is 15, and that's when we would be at the top. And then what I did was I divided things kind of equally in between that. So, and that's something that most of you, I'm sure, are really very good at. If I actually plotted those heights over time, and I actually did 2 full cycles, I went up to 60, I would get a graph that looks something like this. Most of you have seen some trig before, and so you might recognize this as what you might say is either a sine or a cosine function. We could write it using either of those. It's probably a little more closely related to a cosine directly, but like I said, it's a sine or a cosine function.